In this video, we will talk about how to check if a vector is an eigenvector. So here's our definition. Given matrix A and vector x, we say that x is an eigenvector if we can write the following equation. A times x is equal to lambda times x, where lambda is just some number. So let's check out an example. Let's say we have matrix A right here, and we want to know, is this vector x an eigenvector? Well, the way to figure that out is we have to first multiply A times x. So what is that? So remember, when we're multiplying a matrix like this with a vector like this, we can say 3 times 2, so we'll say 3 times 2, plus negative 2 times negative 1, so negative 2 times negative 1, plus 2 times negative 2, so 2 times negative 2. And then for the next row, we'll have 1 times 2, so 1 times 2, plus 2 times negative 1, plus 1 times negative 2. And in the last row, we'll have 0 times 2, plus 2 times negative 1, plus 1 times negative 2. So let's see what we get. 3 times 2, that's 6, plus, this is a positive 2, so 6 plus 2 is 8, minus 4, we get a 4 right here. Here we have 2 plus a negative 2, that's 0, plus a negative 2, so we get negative 2. And then in the last row, we get 0 plus a negative 2, so negative 2 plus a negative 2, that's a negative 4. So when we do A times x, this is what we get. Once we have this vector, we have to ask ourselves, is there some lambda value that we could have multiplied the x values by to get this vector? Well, the way that we can check that is we can say 2 times what would get us this value? Well, 2 times 2. Okay, negative 1 times what would get us this value? Well, also times 2. And then negative 2 times what would get us this last value? Well, that would also be a times 2. So we can see that 2 is the constant that we can multiply x by in order to get this final vector right here. So we would say that, yes, x is an eigenvector. And moreover, we can say that lambda, this is actually the eigenvalue, is equal to 2. All right, let's check out one more example. Let's say we have the same matrix A, but now we will have a new vector x, and we want to know, is this vector x an eigenvector? Well, we'll do the same process where we say, let's just do A times x, and let's see what we get. So first we get 3 times 1, 3, plus negative 2 times 1, so minus 2, plus 2 times 1, so plus 2. In the second row we get 1 times 1, which is 1, plus 2 times 1, which is 2, plus 1 times 1, so plus 1. And in the last row we get 0 times 1, which is 0, plus 2 times 1, which is 2, plus 1 times 1, which is 1. So this can be simplified to 3 minus 2 plus 2, that's 3. 1 plus 2 plus 1, that's 4. And 0 plus 2 plus 1, that's 3. So now we have to ask ourselves, is there some lambda, so some number that we can multiply this original vector by to get this vector? Well, notice to go from 1 to 3, what would we have to do? We would have to multiply by 3. To go from 1 to 4, we would have to multiply by 4. And to go from 1 to 3, we would have to multiply by 3. So since these values are not all the same, it means that there is not some lambda value that exists that we could multiply x by to get this resulting vector. So we would say that no, x is not an eigenvector. So those were a couple examples of how to check if x is an eigenvector of some matrix A.